Hello and welcome back to the shop. And I know it's been a long time between last video and this video, but just been running around like crazy trying to do work stuff and keep my clients happy. With everything that's going around right now, I do commercial refrigeration. As some of you know, a lot of my clients are restaurants, so basically just been trying to keep them up and running through all this craziness here. But we've been steadily working, and you know, we've lost clients because they've shut down, but none of us have been laid off or anything like that. But just been doing projects here and there in the shop when I can, mostly just little stuff for friends, nothing really worth videoing, and a lot of it I just kind of wanted to blow up steam, come down here and not have to worry about videoing. I just actually finished rebuilding this toolbox. This will be on another video, but today's project we're going to be concerned with a project I have left over from the 13-inch lathe. So we are going to be building a drawbar for the Collet system on the 13. This 13 is a little bit different than most. It is a small bore 13, so it has an 1 inch through hole and an 1 7/8 spindle thread. Unlike the, I think it's 2 1/4 inch, and I forget, is it 1 3/8 spindle through hole that the large spindle 13s, I think, don't quote me on that, but I know that the large spindle ones take 5C collets. This takes 2A collets. The same collet size as the small spindled heavy 10, the 10R, which is where I got these collets from, and I'll show you that. So I'm dealing with a 3/4 inch drawbar. I need a 3/4 inch is the largest 2A collet, and 2A collets are kind of hard to find, but I did find a fair bit of them locally actually, so which is why we're taking on this project. So why don't we come over here to the bench and I'll show you exactly what we have to build and how we're going to do it. Okay, so when I bought these collets, it came as a set. There was 25 collets, 25 regular collets, and 3 machinable collets. And it came with the lever closer from a 10-inch lathe. Now, the 10-inch headstock is physically shorter than the 13. So to be able to use this on the 13, I would have to somehow figure out a way to lengthen this drawbar. Also, on the end where the spindle gear is, on the outboard side of the spindle that drives your gearing for your gearbox, there's an extension that's supposed to slip over there to replace that gear, and it would mesh with this keyway here, and then that would rotate with the lathe and do all that jazz of tightening and closing, and then you would have your arm mounted up to the lever. Now this arm is not for this closer. This arm is for a 5C lever collet closer, which means this is longer. So what I plan was I'll just modify this, and then I'll make a new interior drawbar for this, and then we'll kind of figure out something for this. But the more I thought about it, the more I figured, you know what, this is more meant for a production setup where you're going to do a lot of opening and closing at the same size collet, because to use this, you put the collet in here and you adjust the tension, or you adjust how far in it draws by tightening this, and then you use this to open and close it. And then every time you change a collet, you got to unscrew it and then do that. So the biggest thing was just getting the collets, and the most important piece was the nose piece adapter, which is more or less what I bought it for. So what we're going to do is we're going to go the easy route, and we're going to throw this aside. And what we're going to do is we're going to make a hand lever collet closer. This is the one for my 9-inch lathe that uses 3C collets. We're basically going to make a larger version of this. So all this has is a hand wheel on one end, the tube, threads, and then this little spinning piece here is so it would mesh with the spindle. The spindle has a little taper on it. This would hold still and allow you to turn this to tighten it. So we're just going to make a larger version of this using this hand wheel, which I believe this is like 12 bucks. I bought this from Grizzly. And use this hand wheel, and we're going to use this seamless tubing, which is the correct size. So it's a 1 inch outside diameter and a 3/4 inch inside diameter. Exactly what we need. And we're going to use that. So basically what we're going to do is thread this tube on the idea of one side to be able to take the collet, and then we're going to measure our length, we're going to cut it, we're going to thread the outside of this thread the inside of this, Loctite them together, put a set screw in there, and we're going to call it a day. Now, the biggest part is this thread on these collets is not standard. So this is a 850 thousandths, so 0.850 by 20 TPI. That's what the charts say, and I confirmed it with by measuring these collets. Some of them are slightly smaller because they're worn, but the non-worn ones are right around 850 thousandths. So now what we have to do is figure out what we need this inside diameter to be to thread. Now I could measure this, but the problem is I can physically stick my finger in here and feel a ridge. The threaded section goes down this far, okay, and right up to about here there's a ledge, and that is wear. So this whole outside edge is worn, and you can see when I screw this in, you can see how loose we are in there. So we don't want that kind of fit. So now we have to do a little bit of math and figure out what we need to bore this inside diameter to get the correct thread engagement, and I'll show you how to do that. Alright, everything I'm going to explain is right in the first section of your screw threads on your Machiner's Handbook. This happens to be the 12th edition, and it's page 1265. It's all right here. It's a little bit longer form, but you come up with the same answer. I'm just going to simplify it a little bit. So our thread is 850 thousandths by 20 TPI, so none of those thread charts are going to tell us what we need to bore our tube out to for the minor diameter of our female thread. So here's a simple little formula here to be able to do this. So the formula you want is 2 times the cosine of 30 degrees divided by the threads per inch. Now that's going to equal a 100% thread engagement. So in our case, it's 2 times the cosine of 30, which is 0.866, divided by 20 TPI. So our answer, for me in particular, now this works for 60-degree threads only, is 0.0866. Now that's a 100% thread engagement, which we don't want. We want something like a 75% thread engagement, or in certain cases even lower. So we need to multiply that number that we get by our percentage of thread that we want. In this case, 75%. So 0.0866 multiplied by 0.75 is going to give you 0.06495. So we'll just round that up to 0.065. That's your 75% thread engagement number. That is the double the depth of the thread, okay? So that's both sides of the thread added together. This side of the thread and this side of the thread. So now what we want to do is take our thread size, the major diameter of our thread size, which we know is 850 thousandths, and we want to subtract that answer that we just got, and that gives us 0.785. So we are going to bore that tube to 0.785, and 0.785 is going to be our minor diameter for us to start threading. So that's what we're going to do first. So let's go over to the 13. We'll get that tube all set up, and we'll bore that to 0.785. Okay, alright, so first things first, we're going to dial our pot in here. There we go. That's pretty good. I don't know if, let me see if I can, it's about within maybe 3/4 to 1, somewhere in that general neighborhood. Perfectly acceptable for what we're doing at the moment. So now we're just going to face this, and then we're going to start boring it. I'm probably going to bore it, so in other words, let me grab a collet. So the threads on this are about 3/4 of an inch. I'll probably bore it a little bit more, maybe down to about an inch or so, just in case these threads out here ever get munged for any reason. We can just face that off and still not have to remake our entire drawbar. So we'll probably bore that out all the way. And to do that, or to make sure that I'm probably do. I have an outboard, I have a dial indicator mounted to my carriage, so what I'll do is I'll just set that to where I want it. Right about there. Okay, so just get this a little more square on. Alrighty, let me just grab some safety glasses and we'll get going. Alrighty, so let's go ahead and face this off first. Ready? Believe it or not, that is 785 on the nose by my calipers. Okay, so we should be able to start threading. Let's just feed this guy in. Alright, looks like I'm touching there. We're just going to make sure that that is 20 threads per inch. And it is. Okay, let's get some cutting oil and we're going to continue. Okay, let's see where we're at. Okay, we definitely start, but we're definitely tight. So a few more run throughs, and we should be golden. Alright, that's actually a pretty good fit. I actually want it slightly looser just so that the threads themselves aren't locating the collet, that the taper on the actual nose piece will locate the collet. But you can see, I don't know if you can watch this slot right here, or if it shows up, I'm not sure. But I have a tiny bit of wiggle room in there, but I could use just a hair more, just for my own satisfaction. You can see it's a lot tighter than the one that's on the bench, the original one. That had a lot of wear in it, which is why I didn't use those threads as a gauge. So we'll take a little bit more out of that, not much. Okay, let's try this again. I'm just looking for a slightly looser fit, and that's what I'm looking for right there. You see, I got a little bit of wiggly room, but I'm not crazy slack.